Hello, Professor. Today we are Group E, and we will introduce our project. And my name is Jia Chang.
I'm Pang Zhenyu.
My name is Zhang Xu.
And my group member will introduce our PPT first, and I will show how it works.
Today we will present our project titled ESP32. This is the monitoring system for temperature, humidity, water leakage, and door state. This project was completed by Group E, and it focuses on designing and implementing a small-scale IoT monitoring system using a ESP32 microcontroller and multiple sensors. In this presentation, I will first introduce the overall project overview, followed by the system architecture, then explain the hardware and the firmware design, and finally show the test result, consolation, and reference. The main aim of this project is to demonstrate a completed IoT engineering workflow from sensors to cloud visualization. This slide shows the project overview. The objective of our project is to build a small IoT monitoring node that verifies the full end-to-end process, including sensor selection, hardware wiring, firmware development, update upload, and dashboard visualization. The monitoring target include indoor temperature and humidity measured using a DHT11 sensor, water leakage detected by analog water sensors, door open or close status detected using a MC38 magnetic read switch. The core hardware platform is the ESP32 War Room 32, and all data is transmitted to the cloud using Wi-Fi. This slide presents the system architecture. The ESP32 acts as a central control unit. It collects data from all sensors, processes the signal, and sends the data to the cloud platform through HTTP requests over Wi-Fi. The figure shows the actual prototype setup, where the ESP32 and the sensors are connected on a breadboard, representing a typical low-cost IoT prototype architecture. Next, this slide focuses on the hardware design and wiring. Each sensor is connected to a specific GPIO pin on the ESP32. The DHT11 uses a digital pin for temperature and humidity measurement. The MC38 magnetic switch uses a digital input to detect door state. The water sensor is connected to an analog pin to measure water pressure. The wiring design is simple and clear, which help reduce noise, improve reliability, and make the building easier. Okay, the next one.
For this slide introduces the core firmware design. The firmware on the ESP32 is responsible for number one, connecting the device to the Wi-Fi network. Number two, reading sensor data at fixed intervals. Number three, formatting the data into HTTP requests. Number four is uploading the data to the cloud platform. The code is modular, so each sensor is handled independently. This makes the system easier to maintain and expand in future work. Here we show the cloud platform configuration using Sense Center. Each sensor is registered with a unique sensor ID, and different widgets are configured on the dashboard, such as numeric displays and time series charts. This configuration allows real-time monitoring and confirms that data uploaded from the ESP32 is correctly received and visualized. Slide 8. This slide presents the test results. From the recorded time series data, we can observe continuous changes in temperature and humidity, and clear digital translation when the door is opened or closed. Last one is immediate response when water is detected. These results shows that the system is stable and responds correctly to environmental changes. This slide shows the conclusion and the future outlook. In conclusion, our project successfully demonstrates a complete ESP32-based IoT monitoring system, covering hardware design, firmware development, and cloud integration. In future work, this system can be improved by adding more types of sensors, implementing alarm or notification functions, and optimizing power consumption and system security. This slide lists the reference used in this project, including sensor data sheets and IoT platform documentation. That's all for my presentation, and let's turn to my another group member.
This is Think Center, and this is our codes, and this is water sensor, and if you push in and detect the water, it will shows leakage, and for the water it will change. Okay, just like this. And this is the humidity and the temperature sensor, and I put here to detect the temperature and humidity. And this is door sensor. Door sensor is like this. Now it's open, and I will get my partner to get help.
And when the door closes,
it will show 0, and when the door
is open,
it will show 1. Okay.